Hello Math 7 students, this is Utah Middle School Math Project 4.2H, More Proportional and Non-Proportional Relationships. The whole point of what we're going to be going over today is to review when we can identify when a relationship is proportional and when it is not proportional. To get started though, we've got a warm-up here, this quick poll. Is this a proportion? Now students in class have already answered this question. Online learners, pause the video long enough to be able to answer and explain, and continue once you have done so. Okay, the correct answer here, as we've mentioned in class, is that this is not a proportional relationship. The reason I know that is because we have mentioned in the past that all proportional relationships are in the format, or have equations in the format y equals kx, where k is the constant of proportionality. And when I look at this equation, y equals 3x plus 1, I can see that it's kind of in that format. It starts out that way, y equals kx, where it looks like k would be 3, but then we've got this here at the end. This plus 1 is not part of that format. We have mentioned that as long as all we're doing is just multiplying, then it's okay. So here we are multiplying, which is great, but the part that's not great is the fact that afterwards we add 1. So when we add to an equation, that makes it not proportional. So it's not proportional because of the plus 1. Tying it back into our previous lesson, that's like when Barb started with 6 gallons of water in her pool, or Allie, I can't remember who it was. They started with 6 gallons of water in their pool. This is like this person starting with 1 gallon of water in their pool. Or it's like when we go to the Maricopa County Fair and we don't have to pay to get in, but we go to the Walker County Fair and we do have to pay that $1 just to get in, as well as paying for each ride. So when we have this extra thing here, this adding, or if it were subtracting, that would make it not proportional. Before we dive into our lesson, I want to review some proportional vocabulary. Again, we're going to be testing very soon, and so these are all the vocabulary words that we have been talking about, things that are going to be coming up on our review and our test. The first is a proportional relationship. A proportional relationship is a collection of equivalent ratios. We've been talking about proportions for so long that maybe we forgot that we started by looking at equivalent ratios. I've put in here, equivalent ratios are proportional. This just means if we have something like 1 sunflower to 3 roses, an equivalent ratio of 2 sunflowers to 6 roses, that's proportional. We have equivalent ratios. I'm going to skip these part to parts and part to whole for a little bit. I want to come on down here to the constant of proportionality. The constant of proportionality is the number that is used to multiply across a table in a proportional relationship. We usually use the variable k, and this year we've usually been using the abbreviation COP. The constant of proportionality is the same as the unit rate, but you can see in this table we're going forwards across the table by multiplying by 5. And I'm multiplying by 5 everywhere on that table to go across. 3 times 5 is 15, 5 times 5 is 25, and 8 times 5 is 40. And it tells us here at the end that the constant of proportionality is the same as the unit rate. And the unit rate is handled just a little bit differently. It's a ratio of the first quantity per 1 of the second quantity. It is the same as the constant of proportionality, but we look at it a little bit differently. Instead of just the number 5, we would say something like 5y per 1x, or really the y and the x would be replaced with certain things like miles per hour, where the unit rate ties in the units of measure. Key thing is that these are the same. K equals 5 and 5 over 1 all simplify to 5. Now let's take a look at our 4.2h. Okay, I thought it disappeared for a second. Explain how you can determine whether a relationship is proportional or non-proportional when I'm looking at just a table. So we kind of mentioned that just barely on the vocabulary. If I'm looking at a table, how can I tell if it's proportional? What if I'm looking at a graph? How can I tell if it's proportional? And we just practiced with the warm-up. What if I'm looking at just the equation? How can I tell if it's proportional? Before we discuss as a whole class, I want you to take a minute and I want you to work on this with your groups. See if you can come up with ways for each one of these representations. Online learners, give it a try, pause the video, and write down your thoughts. How will we do it for each one of these representations? Pause the video now. We're going to come back and we're going to discuss each one of these pieces individually, but I want to start with looking at tables because right below that we have some tables that we can look at examples. So when I'm looking at a table, how can I tell if it's proportional or not? Kaden S., how do you know? Yes, we should be able to look at the table and find the unit rate / the constant proportionality. So I'm going to put, we should find the unit rate / constant of proportionality. That's fine. You can write COP. What exactly is that going to look like if I'm finding the unit rate or constant proportionality? Like, how do I look at that table and find that? How can I tell if it is proportional or not? Luke, can you add to that a little bit? Perfect. So just kind of summarizing what constant proportionality means, we should be able to find a number that we multiply across the table. Find a number that we use to multiply across the table. And it has to be the same number everywhere in that table, right? Has to be that same number going all the way through. Any other ways that we can tell just by looking at a table? Is there anything else anyone wants to add? No? I'll give you one. What if the table has an x that is 0? I want to tie it into looking at graphs, so I'm going to skip ahead to that one for just a second. If the table has an x that's 0, then what should it also have? Let's pause for just a second. Let's skip ahead to graphs. When I'm looking at a graph, how can I look at that graph and tell if it's proportional or not? Leah? I'm going to change just one thing. It doesn't have to start at the origin, but it has to go through the origin. Yep, so linear, which means it's a straight line. That can go through the origin. So think about that then. If it's going through the origin, I'm trying to draw neatly and it's not working out. If it goes through the origin, what is the value of the origin? What is the value of this point right here? That's probably hard to see. Let me move it to a different color. Is that easier to see? What is the value right there? Emery? Is it 0 for what? How far over am I going? 0. How far up am I going? So what is the value? It's the 0 for the x and the y, where both the x and the y are 0. Remember, this is our x-axis and this is our y-axis. So if the table has an x is equal to 0, what should the y value also have? It should also have a 0. That could also be a good place to start, a good clue to look at some of these. Now, that's enough to get us started. We're going to come back to the equations in just a second, but I want to practice the things that we just talked about. Here are a bunch of tables. It says determine whether the tables show a proportional relationship between x and y. Just a brief explanation is good because I know you have a small amount of space there. And then for each table that is proportional, let's make sure that we're also practicing that skill of writing the equation. Let's start with the first one. Is it proportional? I don't really want to deal with the half and 1 right now. We can come back to that. How does a 3 change to a 6? Anyone know that math fact off the top of their heads? Birdie? Just 2? Add 2, divide by 2, multiply by 2. Exactly. That's a key thing because that's what we wrote down up here. Is we need to find a number that we use to multiply across the table. So 3 times 2 is 6. Can I take that and multiply, take this next number 5 and multiply it by 2? Yes. Does it work? Yes. And 10 multiplied by 2, does that work? Yes. Does it give me 20? Yes. Yeah. What about 1/2? 1/2 multiplied by 2, does it give me 1? Yep. So I'm going to go ahead and say yes, this is proportional. What's a good explanation? I think that the best explanation, if you're saying that it's proportional, tell me the constant of proportionality. And I think that's a very nice, short explanation that does the job. How do we know? Because the COP is what? 2. And since it's proportional, let's make sure we write the equation. How do I go forward in this table? I start with x, I go forward by multiplying by 2, and then I get y. And it's just that simple, x. Going forward, multiplying by 2 is equal to y. There's your equation. If you wanted to write it in reverse, y equals 2x, that's perfect. Okay, you ready to have some fun then? I want you to work on the next ones with your groups, B, C, and D. And guess what? If you're stuck, remember all those words that we just wrote down up here? Stop being stuck and just read those words and do what it says. Practice this with B, C, and D. Online learners, pause the video to give it a try. We'll go over the answers. Should take you roughly 2 to 3 minutes. Pause the video now. All right, let's take a look at part B. Do you remember when I said up here that if the table has an x of 0, then it should also have a y of 0? Let's take a look. Do you see an x of 0? Does it have a y of 0? Yep, so that's a good place to start. It doesn't tell us 100% sure that it's proportional, but it's a good place to start. So let's try and go forward. How does a 2 change to a 1? Maybe you don't know, so maybe you had to work backwards and go 1 divided by 2, and you got 1/2 or 0.5. So how do I go forward? I multiply by 1/2. Does it work here too? 5 times 1/2, is it 2.5? Mm-hmm. And this is why I put this one in there. I haven't taught you guys negatives yet. But do we need to be freaked out about that? No. We found the constant proportionality down here, and we just need to check it. So in our calculator, it looks like this. Do you see how it says -2? I should be able to take this -2 and go forwards across the table by multiplying by 1/2, and I hope that it's going to give me -1. Let's test it in our calculators. This is what you should do. Where's the negative sign? Hint, it's not this one. That's your subtraction sign. Your negative sign is below the 3. -2 times, I'm going to type in that fraction 1/2. -2 times the fraction 1/2. I really hope that it gives me a -1, because if it gives me a -1, then it's going to be proportional. Is it? Yep, it is. Okay, so we don't need to freak out about the negatives and things you haven't seen, because you know how to work the problem without it, and then you just check it. So, is it proportional? Yes. What's my explanation? Just tell me the constant of proportionality. The COP is 1/2. And so what's the equation? Everywhere in this table, I go forwards by multiplying by 1/2. So I could even take the x, multiply the x by 1/2, and I get y. Or if you wrote it in reverse order, that would be y equals 1/2 x. Someone needs to turn off their cell phone. I shouldn't be hearing phones ringing. Part C. Again, I see an x value of 0. Do you see it? If it's proportional, what should the y value be? Ladies and gentlemen, we are not distracted by the ringing cell phone. We are paying attention to what I am saying. So let's refocus. Since the x has a 0 in it, if this is proportional, what should this be? 0. Is it? Do I even need to go any further? No. However, I'm going to prove even more that it's not proportional. How does a 1 change to a 3? We multiply by 3. How does a 2 change to a 4? Multiply by 2. How does a 3 change to a 5? Multiply by 5/3. It's okay if you don't know that. The fun thing, or the thing to note, are these the same number? No. So my explanation can be one of two things. I can say no, because there is no COP, which means, do we need to worry about an equation? Nope. You can also say x is 0, y is not 0, and it should be if it were proportional. There's my explanation. D, last one. Oh, I see a 0, and the y is also 0, so I can say it's proportional, right? Nope. We still need to check. 1 times 3 is 3. 2 times 3 is 6, not 4. So when I try and multiply by 3, I get something different. And here, when I try and multiply by 3, I get something different. So is this one going to be proportional? Nope. Because I would want it to be 9 and it's 5. So if it's not proportional, do I need to worry about the equation? Nope. And I'm just going to put no COP. The next one you're going to answer so quickly, because we already said, when I'm looking at graphs, what do I want to look for? I want them to be linear, meaning a straight line, and I want it to be able to go through the origin. So give it a try here. For A, B, C, and D. If you can write the equations, then that's great. We're going to practice that part together. But I want you to take just 60 seconds, and I want you to identify whether or not these are proportional relationships. 60 seconds is all you get. Ready, set, go. Online learners, pause the video until you're ready. Okay, if we're looking for straight lines through the origin, is A proportional? Yes, because it's a straight line that goes through the origin. So my explanation is just going to be linear through the origin. We'll get to the equation in just a second. We'll come back. What about this one? Is it linear? Does it go through the origin? So, yes, it's proportional. How about C? Is it linear? Try again. Is it linear? Yes. Does it go through the origin? No. So is it proportional? No. Explanation: doesn't go through the origin. And D. Yes, because it's a straight line that goes through the origin. Remember, we talked about that. That's our 0, 0. Does it go past that too? Yes. Yeah. Is there a problem with that? No. It still is proportional. So yes, linear through the origin. We'll write equations again in just a second. I want to skip ahead for just a second. We're going to do a homework problem real quick. I want you to look at homework problem 3. Oh man, I lied to you. It's not on here. And that means it's on tomorrow's assignment, so we'll talk about it tomorrow when it comes up. Let's write equations for these really quick. I want us to return to this, because I didn't read this part, but I'm going to now. Remember how the unit rate is the same as the constant of proportionality? Have you heard me say that before? Have you? Yep. And this also tells us that we can find the unit rate on the table or the graph, which is what we're looking at now. And if I'm finding the unit rate, what am I also finding? The constant of proportionality. So if I'm finding the unit rate, I'm finding the COP. And where do I find that? I find it where the x value is 1. So let's go take a look at our graphs. Where is the x value 1? Oh, right here. What is that value? Let's go up. That value is 6. So what is the constant of proportionality? 6. So what's the equation? Y equals 6x. Or if we go in reverse order, yep, x, constant of proportionality, and unit rate is 6. So x times 6 equals y. This one's a little bit tougher. Here's our x value of 1. Let's go up. Oh no, how far up am I? Halfway between that 3 and that 4, right? Let's take a look at somewhere else where I can judge and see. Here is going over 2 and up. What's that amount going to be? 7. So think about that. What's 7 divided by 2? That's 3.5. Is that what we guessed it was going to be? Yep. So did we find our unit rate? Do we know our constant proportionality? Yes. Can we write an equation? Also yes. Y equals 3.5 x, or if we write it in reverse order, like I know you guys like to do, x times 3.5 equals y. We don't have to write one for C because it wasn't proportional. And I'm done giving you guys help. D, write the equation. Work with your groups. Let's take 30 seconds here. Online learners, pause the video. We'll come back together. Okay, this one was tricky because here it says 3. So where would the 1 be? The first line. We go up. There's the equation. What's the value there? 3. So what's the constant proportionality and unit rate? 3. So what is that equation? Y equals 3x. Is that what you got? Beautiful. Reverse order if you like it that way. X multiplied by 3 equals y. Is this kind of tying in everything we've done all unit? Is this helping you feel good about things? Let's go back. We have one last thing. When I'm looking at equations, and this ties into our warm-up, when I'm looking at equations, what do I want to look for? Quick discussion with your groups. Talk about what you talked about at the very beginning. Looking at equations, what am I looking for? Okay. I hope that part of your discussion included this. They should be in the form y equals kx, where what is k? That's our constant proportionality / unit rate. And that means that the only thing that I should be seeing in the equation is just multiplication. Because as we saw in our warm-up, when I included that addition, when I had the +1, it made it not proportional. So I'm going to put multiplication only, and then I'm going to remind us that means no addition. So if addition is not okay, is subtraction okay? No. So let's re-add that. No addition or subtraction. If multiplication is okay, is division okay? Yeah, good. Division is okay. Multiplication or division only. And let's talk about why. It's going to tie in to some things that you already know. Like, you probably noticed that on this table, we could write this as x divided by 2 is equal to y, right? Because how does a 2 change to a 1? We can divide it by 2. But I've also really practiced with you guys writing that division relationship as a multiplication relationship. But if you see an equation that has division in it, it just means it hasn't been changed back into multiplying by a fraction. But it would still be okay. With that in mind, let's finish up. We have these last couple problems down here. Determine whether these equations are proportional or not. Quickly go through these with your groups. A quick yes or no is all that we need. Don't worry about the explanation because we're short on time. Ready, set, go. Online learners, pause the video. A, is it proportional? Yes, because all we see is just multiplication only. Or yes, we can see the unit rate, but we can see the COP, multiplication only. B, is this proportional? It is proportional. We talked, is division okay? Yes. Is this division? Yes. Okay, take a look. We can always change this because remember, what this is really saying is divided by 3. we can change this to multiplying by the reciprocal 1/3 or 1/3. Does that look like a proportional relationship now? Yep. So I'm going to explain by saying this is the same as y equals 1/3 x. C, is C proportional? No, because the plus 1. So my explanation is the plus 1. D, is it proportional? It is. It's just multiplication. Yes, we might be multiplying on the wrong side, but is it just multiplication? Is it just multiplication? Yes. Here's how I could fix this if I wanted to. I could double half. If I double half, I get 1. But if I'm doubling this side, I need to double this side. X doubled is 2x. That's my explanation. Same as y equals 2x. Or I could say only multiplication. E, is it proportional? No. Why? Has addition. F, is it proportional? Yes, it's only multiplication. Your practice problems are the rest of that packet, the homework section for 4.2H. Make sure you submit that online. Thanks for watching. We'll see you next time.